Hey everybody, welcome to Deterministic. I'm Brandon Conkle, and this channel is where I explore different ways to embrace more determinism in our programming because I get tired of the chaos that we deal with from day to day. I want my code to work the way I intend it to the first time without having to test endlessly and deal with all kinds of chaos. So today I'm going to continue the session that I started a couple of days ago. Someone had visited my repository, my example caster repository, demonstrating how to use the async-graphql library in Rust. And async-graphql is an async first library that uses the Tokio runtime to handle resolving GraphQL queries and allowing you to wire in handlers with context and data and all of that. It's a fantastic library. It's very capable. It's able to cover a lot of what GraphQL supports. And so I'm excited to dig in a little further. Where I left off on the last stream was I was looking into partial updates because of a question that was posted on the repository. So I'm pulling up the repository right now so that I can show off the question. There we go. Actually, there we go. So this is the REST example caster API project. And so I'm going to go into the issues here. And Frederick Ors submitted a question here 11 days ago. I'm a little bit slow in getting to it. So last time, his question was regarding partial updates. And so I'll go over again what the dilemma is with partial updates. But it is a situation where you have an update that you want to be able to support changing some fields, leaving other fields unchanged, but also supporting optional fields. So there's a difference between saying leave this field unchanged or set this field over here to a none or an empty value. So in the JavaScript world, I would typically handle this with a differentiating between null and undefined. So if a property was undefined, that can happen either in JSON by setting it intentionally to undefined or by just omitting that property from the object entirely. There are a lot of programming languages, though, in which omitting a property entirely is not even supported. So in order to take advantage of this, you need a programming language that can send a null or an undefined separately. So in this case, my original approach to this was to use a double option, an option. So the way that makes sense is that if you send just a top level none, that means you want to leave the field unchanged. But if you send a sum of none, that would mean that you want to clear the field out, that you want to set that to none or to empty or whatever you want to call it for an optional field. Or you could set it to some value. And that worked in the other project that I was talking about where I had implemented this in a different context. It wasn't in a GraphQL context. It wasn't like this. So I attempted to approach it this way the other night and couldn't figure out a way to differentiate between the wrapped options in the GraphQL types. It collapsed it down into a single optional field in the GraphQL schema. So I did a little bit more digging and found that there actually has been some progress on supporting this built in through async-graphql. I love the team behind async-graphql. So they have a MaybeUndefined type that exactly handles this use case that we're looking for. So in my journey towards discovering all this, I started out here on Stack Overflow on this. How can I distinguish between a deserialized field that's missing and one that is null? And in this case, they end up going down the route of talking about Serde deserializers, a custom deserializer, which is a reasonable answer. That works, but it's not very ergonomic. It's hard to work through. So I kept looking, kept digging to find better answers, and I think yes, right here was another Stack Overflow that mentioned the the double option pattern, the pattern that I had implemented on a different project in a different way. But then beyond that, I found out that there is a library called serd-with, or serd-a. I always say it's serd, but it's serd-a because it's short for serialize, deserialize. But this serd-with package has a double option built in that helps differentiating in this case. But to go even further, like I said, async-graphql itself has a MaybeUndefined type. It's not in the main documentation. You have to dig into the actual docs crate to find it. But this package here does exactly what I'm looking for, like right down to the descriptive language that I'm looking for to help make it more maintainable afterwards. So in this, you've got a check for is null, is undefined, or it can be a value. That's the third arm that they don't show here. But this is definitely the right way to approach this in my case, or in my context here. So to implement this, I kind of took a journey through a couple of different impacts that it had. So I'll re-implement it here live and kind of walk through how I got to the final point where I think works really well. It's not perfect. There's more that I wish I could do with it, but I'll go ahead and get started with the show entity. So I've got my app divided into two main portions. I've got my apps portion. This is what I consider my entry points or my running processes. So I'll have the API process here. Later on, I might add more processes to this, like Lambda functions that operate asynchronously, like a worker behind the scenes or something like that, or responding to DynamoDB events or things like that. But I keep the entry points separate from the actual internal code. I call that the libs function, or a folder here. And I use Cargo's workspaces feature to separate those out and get reusable code internally so that I can kind of mix and match my entry points as needed. So if I end up wanting to split an entry point apart, or if I want to break it up into several pieces or merge it into something singular, I can do all that without actually refactoring the business logic. I just have to update the entry points. And so my domains, I like lightweight domain-driven design. I also like CQRS a lot, but I'm not using it in this project. But I've got my domains separated out into basically entries or entities in this case. But the idea behind the domains is that you co-locate, you group together components that are related to a particular business domain or business concern. And you separate that in a clear way from your persistence layer. So in this case, I'm going to go to the shows entity here. So you can see I've got my database model here. I've got my mutation types, my query types. These are all async GraphQL types. I've got the resolver here and the service here. And so I'm going to hone in on the mutations here because this is the big dilemma. The update show input type here. This is where the dilemma that Frederick's post over here pointed out, where you can't set something to empty or none, because in the resolver over here, basically all it's doing, where's the update? Yeah. No, I'm sorry. It's not the resolver. It's the service that's doing this. There it is. So right here is where the relevant action happens. And this is just checking to see, is it some or is it none, based on the type encoded with async GraphQL here. And if it's some, then go ahead and update it to that. And if it's none, just ignore it. So in this case, there would be no way to set the show summary. Show summary could be an option of a string. There's no way to set that to none after you set it to a value. And so that's the limitation of the update function as it's written now. The just a quick aside, the data flow for this comes in first from the app. The request comes into the app and is resolved by the GraphQL resolver, and handed off to this resolver function here, the update show function. And so the purpose of the resolver is to attach an entry point to a service, so to perform business logic. And so the resolver here handles everything that's specific to the GraphQL entry point. So it's handling all of the outside concerns before you want to actually invoke the operation that the request was asking for. But then once you get into the service, things like authentication and authorization, those are already decided. Any kind of derived values for the input is handled. Well, it depends on the situation. You want to handle most of your business logic in the service, though. So anything that's agnostic, anything that could be shared between different entry points goes into the service layer. And so then it uses, I'm using CORM for my Postgres interaction here. I've got a Postgres instance running behind the scenes in Docker, or I would use Aurora Postgres in AWS context. But that's how the data flow works. And so this mutation is the input type, essentially. It's using async GraphQL's input object derivation. I don't know the right word for that. But it automatically knows about the option type. It's got an implementation of input object for the option type. And then also, what I just talked about, the MaybeUndefined, it has an implementation of. So I will change that first property there to a MaybeUndefined, because you see the title is required. That's not one of the optional properties. And then summary and picture, those are the two optional properties. So for the title, actually, I don't even need MaybeUndefined for the title. I can leave that as an option because we don't need to have the capability of setting that to none. But for the rest of these, what I'm going to do is let me double check and make sure I'm approaching this the correct way. No, I'm not. I was starting to wrap the option string, but no, I just need MaybeUndefined, because it handles both the cases that I'm looking for. So undefined is going to indicate that we want to leave the property unchanged, and null is going to indicate that we want to set the value to none, since the underlying type is an option string. So right off the bat, you see we get some helpful errors from the type checker. So first of all, I'm going to look at the dummy deriving error here. And what it says is that the trait dummy faker is not satisfied here. And this makes sense because the MaybeUndefined type, it comes from the async-graphql crate. So it doesn't know anything. Well, it could know something if the maintainers of the async GraphQL library used Faker and they went ahead and implemented the dummy or derived the dummy trait for the MaybeUndefined type, then this wouldn't be a problem. But in this case, the developers of async GraphQL are not using the dummy or the fake library. And so I get this error saying, hey, you can't create a dummy of something that we don't have a derived trait for. So it complains about the MaybeUndefined. So there are a couple of ways to solve this. I'm going to go about it probably the most blunt way at first, because that's the way that I think I got working the best. But then I'll point out the way that I wish it could work and talk about a limitation of deriving traits that come from two separate, deriving a trait from an external package for a type from an external package. Rust has some big problems with that for good reason. But first of all, I'm going to take the dummy derived definition, or the, what's that called? The directive, I guess, off of there. And then I'm going to go ahead and implement dummy manually. This is the kind of awkward part that I don't like, but it's the best way to go about it here. So I'm going to create an implementation of the dummy faker type for my update show input type. And I'm going to call the function dummy with RNG. because that is the wow, I didn't realize I needed to implement both of those, because in my implementation that I already did previously, it worked without implementing both of those. Yeah, I'll just keep going the way that I did before. It didn't actually make me implement the secondary. I just implemented dummy with RNG. So interesting. All right. Anyway, I'll go ahead and implement dummy with RNG. And so this is to figure this out. I actually went through the source code of Faker and kind of looked at what some of their other implementations look like. So if you go into source, there's their implementations here. I pulled up the option implementation, I believe, which should be in their standard library folder there. So there's option. And so, yeah, you can see I copied the signature from here. They've got the type constraint, making sure that it implements dummy. So everything that you would expect there. So essentially, I copied it for this implementation, but to actually return the type that I'm looking for, this one should just be able to be, yeah, let me bring that option back. This should be able to be just implemented the same way as the inner type on the option there. So I'm doing it slightly differently than I did last time because of my deviation here. Let's see. Oh, in their case, T comes from the type parameter that was being passed in there. So T comes from that constraint there, but I don't need that constraint because I already know the type that I'm working with. So I can just say option and tell it, okay, generate a dummy, because option is one of those types that has the dummy trait implemented for it. So it has that dummy within RNG method available to it. So I can use that here. All right, so now it's upset about something else that I don't believe. Oh, I haven't actually imported the trait faker yet, or the type. There we go. All right, so title is the one that didn't use a MaybeUndefined. So summary and picture, I need to create an undefined for, or a MaybeUndefined dummy instance there. So to do that, there are a few different options there. I could do it one-off for each case individually, and that could get pretty verbose to maintain over time, especially if you end up having a lot of optional properties that you want to include in partial updates. If you've got a MaybeUndefined in a lot of different places, that makes it hard to maintain. The level of care that goes into making refactoring happen increases exponentially the more code that you have. And so creating something that's a little more generic that'll work for a lot of different cases is often a better way to go in these kind of situations. So that's what I'm going to do here. I'm going to create a dummy that allows you to create a MaybeUndefined for anything, or create a dummy version of MaybeUndefined for anything, for any type. So you can see there's some other things here that I'll get to once I finish my implementation here. I'm going to put it in a centrally located place, though. I'm going to, instead of putting it here with my domains, this is something that can be used a lot all over the place. So I'm going to go into my utils package here, and using the cargo workspaces feature. So this is how I can have sub packages inside my crate here. So in my utils crate, I want to create a GraphQL.rs file now to handle my GraphQL utils. And let's go ahead and add it to my live.rs so that it actually gets imported. And then I have some linting set up that tells me, hey, since this is a public field, you need to add documentation to it. That all comes from this .cargo folder up here. I've got a whole bunch of Clippy definitions here, or directives, or whatever you want to call it, to wire in all of the the linting here. So I'm going to say GraphQL utilities. I'm going to be really descriptive and inventive here. I didn't capitalize the U above, so I'm not going to capitalize it here. I like to stay consistent. All right, so I've got my module created here. So now I'm going to create a function here. Now, what I really want to do is implement the dummy trait for MaybeUndefined directly, but I can't, and I'll talk more about why that is in a moment. But first off, I'm going to go with my more blunt implementation here that I got working earlier. So this dummy MaybeUndefined function is going to be a public function. It's going to take a generic type, and then it's also going to take a type parameter for the random number generator. This is just like you saw on the other implementation of the MaybeUndefined that I borrowed from the library itself. So this question mark sized here allows RNG to be dynamically sized. We don't have to statically determine the size up front, but you can only have one of these per struct. This is not a struct though, this is a function, so I don't think that limitation applies here. In any case, just like the other dummy functions, it's going to take the config, which is a faker instance, and it's going to take a mutable reference to the random number generator, and then it's going to return a MaybeUndefined for type T, whatever generic type that we're working with. And in the case of my types in the other file, this is just a string, but this could be anything. So you can see it needs me to import some things, so I take advantage of VS Code to do that automatically because it groups things nicely or sorts them within the groups that I create nicely. So I pull my types in here. All right, so oops, what's wrong with that? Oh, I'm not actually returning anything yet, so it's saying, hey, something's wrong. All right, so I've got the signature set up here. The implementation of, oh, nope, I forgot one thing. I need to add the type constraint because we need to make sure that whatever T that the user is passing in implements dummy so that we can use that dummy with RNG method on it as well. So I'm adding the type constraint here. And a quick aside, let me go ahead and add dummy to the fake. I could have let VS Code do that for me. So a quick aside, there are actually two ways to do this. There's a legacy way to define generic type constraints, and then there's the where clause way. If you wanted to do it the legacy way, it's a little bit more limited, but it works just the same. In fact, it is now syntactic sugar for the more verbose way. But if you wanted to add the constraint in line here, you could do it like that. And that is totally fine. If you can express the constraint that you want to enforce here, then you can put it in line like that. Just know that that was the original version of the feature, and then the where clause was added later on to make it more flexible in certain cases. You won't always need the flexibility, but I've found that it's just nice to be consistent and use it in this form so that your eyes are kind of trained to follow that each time. So I've got the type constraint in now, so I know that any type T that the user passes in is going to implement the dummy with RNG method that we need for it. And so next up, I'm going to do a switch statement, or a match as it's called in Rust. And this, again, I saw this strategy from the fake library itself, one of the other types that it implements dummy for. So it's creating a range from 0 to 2. So in my case, that gives me 3 distinct states to work with. And so this is another fake method here that takes the random number generator that was passed in by faker. And then I'm going to handle each of those different cases. The first case, 0, I'm going to tell it, okay, in that case, return a MaybeUndefined that is undefined. And so then 1, okay, tell me, or this time return the null. And then 2, here's where some magic happens, but I love that it's carefully constrained and well-controlled magic in the Rust world. We're going to tell it to use that dummy with RNG that is there because I added the type constraint here. So we know that we can use that. And then the config and RNG, they come in from the type, from the method invocation on the outside there. So in this case, oh, it doesn't like that for some reason. Let's see why. That's right. So this is not a constant. Like this reads, this type in parentheses here, it really just reads as an integer 32. And so it's telling me that, hey, there's more than just 3 numbers in this series. This is not an exhaustive switch case. This right here is actually one of the really powerful functions of Rust. The fact that it has switch statements or match cases that are exhaustive. That's a feature that I'm more familiar with in languages like Haskell or OCaml that really go to great lengths to make sure that you don't have unexpected runtime errors. And so that's what it's doing here. It's trying to say, hey, there's cases that you might not have thought about. In my case, I already thought about it because my range is only ever going to go up to 2. But to satisfy the type checker, I'm going to give it an underscore that says, okay, any remaining case that didn't fall into the first 2 cases there, this is the default branch of that here. So the default branch uses dummy with RNG on type T that was passed in from the user and wraps that in the value enum variant for the maybe undefined enum. And this is how it generates this dummy value. So if the random number generator comes out as 0, you get an undefined in your tests. If the random number generator comes out as 1, you get a null in your tests. Any other case, you get a randomly generated dummy value of whatever the inner type is that you've passed in. So you can see it is complaining again for missing documentation because this is a public function. So let's see, randomly generate the maybe undefined type from the async-graphql crate. That way I know where the heck that came from, although I guess it's right up there, so I didn't have to say that. All right, so now I've got a nice generic function here that will create a random, maybe undefined value for any value of t that implements the dummy faker trait. What I wanted to do, though, what I really wish I could do is just impl dummy directly on the maybe undefined type. So I'll try that here so that you can see the error message that comes up when I do that. Dummy faker for maybe undefined. Oh yes, I have to add T in here. Just going to use the inline syntax for brevity right now. So dummy faker for maybe undefined T. And then before I even get to implementing the method, it tells me I can't do this. Only traits defined in the current trait can be implemented for types defined outside of the crate. So it's saying since dummy faker comes from the fake library or the fake crate, and maybe undefined comes from the async GraphQL crate, and here I am sitting inside the caster libs crate, I can't do this because if there are competing implementations in some other crate, Rust has no way to know which one to choose. It has no way to know which implementation of this trait should win. If I go off in another crate and implement dummy faker for maybe undefined and do it a completely different way that changes the behavior, Rust doesn't know which implementation to go with. So it implements this constraint of making sure that if you are implementing a trait, then either the trait or the type you're implementing it for must be within the current crate that you're working on. And that's part of what Rust does to prevent you from shooting yourself in the foot. Yes, there are cases where this might be okay. There are cases where you don't have a competing implementation in some other package, but Rust can't deterministically guarantee that. It can't, in its sound type system, prove that that can't happen. And so it errs on the side of caution. And this is why Rust is so groundbreaking, I think. So because of this, that's why I can't just implement dummy for MaybeUndefined. If I had done that, if I was able to actually successfully do that, then here in my mutations, I wouldn't have to worry about manually implementing dummy. I could put dummy back up here in the derive list. And since MaybeUndefined now has an implementation of the dummy trait, it would just be automatically derived. But since I can't do that, since both types are in, both trait and type are in foreign packages, I can't do that here. And so I have to use this somewhat clunky helper function that I've set up. But you know what? It works. Yes, I have to manually derive dummy for my update type, but it's the only one I have to do that for. The other ones I can still use the dummy deriver for, and I can move on with my merry way here. So now I've got everything in my mutations, my input types for GraphQL set up. I've got the MaybeUndefined encoded for my optional properties that I want to support a partial update for. And so now I can see, all right, my service code is not compiling. So this is understandable because it was written for the prior, more limited way where you could only, in a partial update, set something to a positive value rather than setting it to none. So now that we have moved beyond that world, we have opened up the possibility of it being either null or undefined, and allowing that to change the behavior, we have to change the service method that's handling this as well. So I'm going to comment that out. I usually leave commented out code like that to kind of guide myself to see what I was doing before. But first off, I'm going to use a match again, and I'm going to use it for input.summary. And I'm going to say, okay, if it's undefined, now it pulled in MaybeUndefined automatically for me. I don't want to be like, I could go spell it all out entirely like this, MaybeUndefined, and then, oh yeah, I need to actually finish out my case here. If it's undefined, then I leave it as it is, leave it unchanged. I don't touch it. I could do it like this, but I like the more terse syntax like this. When you don't have competing definitions of a type, actually importing them does clean things up quite a bit. So I'm going to come up to the async-graphql use definition here, and I'm going to say, yeah, pull in MaybeUndefined, but then I'm going to say further, let's go into MaybeUndefined and destructure the value, undefined, and null variants for this enum. And that way I can use them directly down here. So now I can just say undefined. So undefined, I do nothing. If it is null, then what I actually want to do is set show summary to none. So this set here, this comes from CORM or CORM. That is the ORM that I'm using that is fully async first. It's based on Tokio. It's made to work really well in this kind of ecosystem that I'm building in. Everything that I'm working with in this project is async first around Tokio. So this set is designed to handle these exact cases that we're talking about, where something can be set to something, it can be left unchanged, it can be set to nothing. So in this case, we're setting it to nothing. And then in the third case, we have the value, and then I'm using the parentheses because I want to pull the wrapped type out of this. So if you hover over it, you can see, oh, okay, well, not until I hit save. All right, not until I actually finish typing what I was going to type, and then it'll show me. But in this case, we'll set the show summary to the value, inner value here. Oh, so first off, you see this is wrong because show summary can be an option string. That active value there, that's what is expecting the enum with the set variant and the unchanged variant. But this inner type, this option string, that's what show.summary is. So show.summary is not a string, it's an option string. So I've got to say set it to some value. And that's what allows me to set it to none up here. So this looks good, but the compiler's still not happy. So let's see what it's complaining about here. It's saying that, oh, if you look at it, input is a borrowed value. And the way that I'm using summary here, I'm telling Rust to take ownership of it. I'm telling it to use it as if it was an owned value. But it's not, it's borrowed. And so it rightfully complains that, hey, this is not compatible with the memory ownership of this value currently. So I'll just borrow that too. And that solves the problem there. It automatically dereferences things inside here and makes that easy to work with. Doesn't it? No, it doesn't. Oh, that's right. Because since it was a borrowed input.summary, the inner value here becomes borrowed as well, which makes sense. It's keeping track of that ownership. It's making sure that I don't have bad memory usage or unpredictable patterns. But since it's a string is really easy to copy to another memory region. I'm just going to clone it. And you'll notice this is not a mutable borrow, so it's immutable. So that means nothing can change it from out from under you behind the scenes. So it's fine to copy that value here, to clone it here. It's not something that'll change randomly when you're not expecting it to. So here is our finished partial update for the input.summary property. So I can delete that, and let me do the same thing now for the picture property. Won't do anything if it's undefined. If it's null, clear it out. Oops, show.picture. And if it's a value, set it to that value. But clone it so that the struct can own it. It's generally best to allow your structs to own its properties unless you have a good reason for it to be a reference. All right, so here we go. Now I have my updated service code here, and everything should be fine, but we've got some complaints. This is the unit tests. So my unit tests are nested inside this tests folder here. And of course, it's rightfully complaining because, hey, this summary is looking for a MaybeUndefined now, but you're giving me an option. So that's not compatible. So let's give it, the original intent of this test was to leave those fields unchanged. So I'm going to give it a MaybeUndefined of undefined. But yes, I can give it the full import like that, but instead I'm going to import it above. But I am not going to destructure the properties because I already have a value from CORM. So I don't want to overwrite that or have to rename that. So I'm just going to leave this as a qualified enum in this case. So MaybeUndefined : undefined. And same for its partner here. All right, so hypothetically, I could run the unit tests now. I think it's going to complain about my integration test, though. Let's test that out. Let's see if it does. So here is my iTerm window. I'm in the Rust example caster API repo right now, and I'm running cargo tests. And so it's going to build things. The M1 chip in this Apple computer really does a stellar job at building. It's actually better than my gaming PC with a Ryzen 7 in it. And yeah, it is complaining. Let's see why it's complaining. No matching expectation found. Okay. So the expectation that it's talking about is coming from the mock that I'm using. What is interesting is that this did not fail when I implemented this first before jumping into the stream. So I'm going to do some live troubleshooting here to figure out why is this happening. It probably has something to do with the variation, because the first time I did it, I made this title a maybe undefined also, even though it didn't need to be. All right, so, oops. It's complaining about the mock shows service get by IDs. So this is not even, this is in the resolver test. Okay. And it's in the episodes resolver test. How fascinating. How does that interact with this? And why didn't I see this before? Yep, it's persistently failing. Okay. So the test that's failing is this get simple test. It doesn't even look like it's grabbing a show as a related result. So I don't understand. Fascinating. All right, so let me look at my previous implementation and see what's different. I don't understand how setting the title as, or leaving the title as a option rather than a maybe undefined, I don't understand how that would impact the episodes resolver at all. So this is an interesting problem. Oh, it has something to do with the data loader. All right, so the data loader is a piece that is tacked on to help combat the GraphQL N+1 problem. And that is put together here in this module. We looked at it in the last stream briefly to explain why I couldn't pull things out of arcs, and I don't see anything wrong with it. So I don't understand why it's complaining here. So, all right, in the resolver test, I've got the mock shows service, and that is being used in the init function. So the init function is called right at the top of the, or towards the top of the test, right? No, they're at the middle of the test. So when it's initializing, it's pulling in the mock shows service. And then the expectation that is set up is a get with an episode ID and a Boolean, a borrowed Boolean value. Yeah, I don't understand how this would impact that at all. So to make sure I'm not doing anything wrong, I'm going to do a quick diff and make sure nothing made it in that I wasn't expecting here. So we've got the dummy pulled out. We've got these two turned to maybe undefined. We've got the implementation here. This pulling in the value. Whoops. There it goes. All right. Got our two switch statements there. Yeah, I don't see anything that's different or that would impact that. So next, I'm going to stash this. I'm going to switch to the main branch. And I'm going to see if things are passing in the main branch. I think they probably are. I'm just mystified as to how leaving one property the same way as it was in this pass. Yep, they did pass. Could have made such a difference. All right. So I'm going to get stash pop to get my stashed properties back, or stashed files back. And next, I'm going to go ahead and make the same change that I did on my last pass through this to see, is it really something that I did differently? So in that case, I changed this to MaybeUndefined string also. So then down here, I needed to also call. Oh, okay. I see what's happening. I didn't actually call my helper function here. Or did I call it something different? I did. Okay. I'm just tricking myself. Yeah. On my first pass, I called this dummy MaybeUndef, which makes more sense. So I'm going to make that change here. I'm going to come back here and oops. Oh no, that was right. And then I'm going to set title to the same thing. This actually fixes it. I'm going to be mystified. So then down here, I do the same thing, but in this case, I do both undefined and null as nothing. And only if there's an actual value provided do we then set the title to input title clone. And I can clear that case. Oh no, I need that to be value clone. It's still not happy. Oh, I need to set it to value clone. That's why it's not happy. All right, there we go. So then that means up here, this becomes a maybe undefined value. So yeah, this is how I had it on my first pass. So let's see if that actually corrects the tests here. It shouldn't, because nothing I changed here should have impacted the episodes type, which is a separate but related type. But somehow it has solved the problem. That is very interesting. I'm going to have to investigate that later. For now, I'm going to leave it as it is because it's functionally, behaviorally the same. And I'll come back to that in a later stream after I've had more time to investigate. I really don't understand why that would cause this problem. All right. Anyway, so there's one last piece to fit together here, and that is the integration tests, right? Let me double check. I might have only had to fix the unit tests. Yeah, in my first pass here, I only had to fix the unit tests, but I wonder why that is. Let me go ahead and pull up the integration tests for show, and let's go look at the update test. So test create requires title, requires authentication. Here's our get show. Here's get many shows. There's update show. Okay. So in update show, oh, I see. It's using update show input, which is automatically derived based on that type that we were working with in the mutations here, that update show input. So maybe just the fact that it's all automatically derived and dummy values are being generated automatically means that the integration test is resilient. And yeah, I'm not doing anything manual here. Yep, so this makes sense. That's why the integration tests are still passing. Let's go ahead and try them out just to make sure there's no surprises like we had a moment ago. I'm going to first do a Docker PS to make sure that my processes are running. I'm using the beta version of Docker Desktop that supports the Apple Silicon. And now I'm going to use my cargo make command. There we go. Cargo make Docker up just to make sure everything is running and up to date. Everything looks good. So now I'm going to cargo make integration to run my integration tests. And these are actually issuing HTTP requests to the Warp HTTP server that I've got running behind the scenes. Or it's actually spawning a new server for each test. And you can see it's using a random port each time, which is actually what Warp does behind the scenes too for spawning threads to handle requests. And it's running through each of these and actually making round trips to the database that's running within the Docker compose formation here. And everything looks good. Everything passes. So I ended up with essentially the same exact implementation that I had before. I've got that in a branch, so I'll go ahead and PR that on the repository, and we'll be able to put this issue to bed. So that is partial updates within the async-graphql library. Now, that's specific to async-graphql, but there are also ways to approach this in other contexts. Like I said, that CERD, wow, that was kind of glitchy. The CERD with library has this double option type, which seems similar to what the approach here that I was looking for. But you can also go look at the MaybeUndefined implementation and perhaps generalize it for your own use if you need it in a different context. It's definitely nice. All right. So I will close out this issue later on. I think what I'll do next is go ahead and move into some WebSocket coding. I'll start setting up the WebSocket route on Warp and some of the machinery that I need to handle WebSocket events. I've done it in a different project, so I'll be borrowing a lot from another project, similarly to how I was borrowing from my other branch here. I'll get more confident and do more things live on the fly later. But for now, I'll follow that pattern. So I'm going to go ahead and take a break and come back probably in about 10 or 15 minutes, 10 minutes, and get started on a WebSocket implementation. All right. Hey, I'm back and I'm ready to get fired up on a WebSocket implementation. I like WebSocket a lot. I've used it, especially in the TypeScript world, quite a bit um, because it's similar to a GraphQL subscription, but a lot more flexible. You can use it for event-driven interactions with the server, and you can push things in a kind of full duplex way that a subscription in GraphQL doesn't let you do. So I'm a fan of WebSockets and how they enable kind of new types of interactions. I'm also interested. I've used WebRTC before for video sharing and also things like triggering events. So that's kind of another approach of doing the same kind of thing. But the WebSocket, I think, is really widely supported and well documented in a lot of cases. I think in the Warp world, Warp is still kind of a minimal library, and so there's not a ton of documentation there. But I was able to dig in and look through a lot of the source code to figure out exactly how things fit together. And they've got good examples. That's one great thing about Warp is they have several different examples of how to do things. And async-graphql as well has that. So anyway, I'm going to go ahead and pull up. I kind of cleared out my branch here for the stream. I'm doing this for the first time, kind of copying off of another project. So we'll see how this goes. So I'm going to start with the entry point. I'm going to go to apps API. So this is my API process, a long running HTTP server that has a GraphQL endpoint. So there's my main module here that this is what bootstraps the process when the process starts up, and then it uses the router module here to set up a warp router to handle all the things. And so currently my router.rs file has a create routes method here, and the creates routes method first supports a health check endpoint, and then it supports the GraphQL endpoint. So this is using Warp's feature of composable filters to put together a set of routes that's kind of the same, very similar way to what you would see with Express in the Node or JavaScript world. I've spent a lot of time in that world, so I tend to compare things to that. And then it's got a few extra things in here. I won't dig into exactly how everything works, but I'll go down here. I've got my GraphQL and my execute function here, and I'll go ahead and add something new to the bottom. I'm going to add the WebSocket handler. Yeah, I can't use 3 slashes because Rust Clippy interprets that as method documentation. But I can use 2 there. I like to give visual separation to my code. I like little things like this that makes it easier to scan with your eyes at high speed. So I'm going to call this events because that's what WebSocket is doing. It's setting up a real-time events interface, quote unquote real-time for your API. The first thing that it's going to take is an arc, which is the atomically reference counted container that is thread safe with the context. And then I'm going to give it the JWix definition. So JWix is an authentication protocol or standard that allows you to share signing keys, rotatable signing keys. And I'm using it with the auth0 to manage logging in. So I want our WebSocket users to be able to log in. So I'm going to use it in conjunction with this. And I'm going to implement the warp filter. I'm going to tell it to return an HTTP reply, and then the error is going to be a rejection. This is really similar to the code above. And I'm going to say plus clone, meaning that the dynamic implementation that I'm returning here is going to be clonable. So within this, I'm setting up a warp path at /events is what this says essentially. I'm going to tell it to use WS. Now, this WS comes from warp. So up here, I've got my filter and my reply. I'm going to add WS here so that I can wrap it in here. And it's just a built-in WebSocket filter from Warp's maintainer. And then next, I'm going to layer in my with context handler, which essentially provides the context, adding a new counted reference to it for use within the event handlers here. So I'm going to clone the context. I don't know what it's upset about here. Oh, it is, but I'm cloning it. So cloning it should move it back to owned context. Let me finish this up and see if there's anything else funny going on. So the with auth takes the JWix key servers definition. And finally, I'm going to add this. This doesn't exist yet. This is going to be a connections handler for WebSocket connections. Oh, I need to import that, don't I? No? Yeah, I shouldn't need to import it. So let's see. I've got a typo somewhere. Oh, I've got impl filter extract twice on here. How did that happen? That's part of what was going on. All right, this is okay because I haven't created that yet. So I'm still getting a problem here. Oh, I bet it's because of with context. Let's see. It's expecting a borrowed. Yeah, and actually, I think it should expect a borrowed. So I think, yeah, I just need to pass it in because it is cloning it right here. So it's already, yeah, okay. It's already expecting it to be a borrowed reference that it can clone. So yeah, passing it in directly is fine. So, okay. So this is my filter. This is my warp filter to handle WebSocket connections. And so now I need to set up my handler. And so the first thing that I'm going to do is create the events folder here. Whoops, because this is going to be a submodule within my apps package here. It's in the apps package or crate or whatever you want to call it because it's part of the entry point. It's specific to this entry point. It's not code that we're going to share with other entry points potentially. So it's its own thing. Now, the way that Rust submodules work, there's a legacy way and then there's kind of a new school way of doing it. And I like this new school way of doing it. So in my events subfolder here, I'm actually not going to have a lib.rs. The legacy way of doing it required a lib.rs in the subfolder. But in this case, I can actually add an events.rs. Whoops, where'd it go? Events.rs inside the source folder here. And this events.rs acts as the lib.rs, but it's a little bit more descriptive about which lib it's working on, essentially. So let me see what should be inside it. Ah, yes. Okay. So I'm going to have a few different things inside it. I'm going to have, first off, some message types for the messages that we're going to send on the WebSocket connection. Oh yes, I'm going to need to add a doc string to that. And then we're also going to set up connections. This is going to be a module that manages active WebSocket connections because we want to maintain those connections in a way that we can use them when a real-time event is triggered that we need to communicate to them, or when they send a message back to us. And then we have a router that's going to be a private module that is used by the handler to figure out where to send things. All right, and so inside my events subfolder here, let's start off with those message types. So messages.rs, and I'll probably just go with the standard ping for now. And then obviously you can layer more complicated event types in later on. So starting off, what I'm going to do is I'm going to call it incoming message. So this is going to be an enum spelling out all the different types of incoming messages that we can receive. And I'm going to give it a ping message, which should echo back a pong. Ping pong. And I'm just going to call it ping. So this is my first event type here, a ping. So next up, I'm going to implement, let's see, I'm looking at what to tackle next here. Let's go ahead and tackle, first off, tackle adding a doc string to this, or the clippy linter will complain. So these are the messages that clients will send to us. So now, let's do the same for outgoing message. This is going to be the pong, which is the response to a ping. All right. So both of these are going to correlate to a warp type. So warp has a generic reusable message type here. I think I need to save it so that it compiles, so then I can hover over it. No, it's still upset about I gave it an events module. I'm not using it, am I? Well, no. It does not like that. I don't totally understand why. I'm not importing events in here. That's probably why. So in my use crates definition here. Oh, wow. Oh, not only do I have to add events.rs to represent this submodule, I also need to import the submodule from the main module. That's what's happening here. So, okay, in my lib.rs here, I need to call out my new module. Yeah, so I'll put it underneath the GraphQL one here. All right. So now, now that this is being pulled in, it's complaining because connection.rs and router.rs don't exist yet, but now they do. So this can stop complaining. Yeah, okay. So now down here, oh, I called it something different, didn't I? No, I called it connection, and then I called it connections here. I think connections plural is more semantic, so I'm going to change that. No, I don't need to refactor right now. All right, so then I'll have to update my name for it here because that is actually looking on the file system for it. There we go. All right, now this is the error that I expect. We don't have a handle method yet. And so it's perfectly reasonable for it to be complaining about that. All right, so I'm going to go look at the messages now and see, do I need to add? Yes, I do need to add one other thing. I was talking about the generic warp message. There it is. Now it's talking about, it's a WebSocket message. Oh, it looks like it's going to change. It says it's going to become a non-exhaustive enum in the future, but later. So I'll have to keep it in mind that I'll have to update this later. What I want to do is make these types interoperable. I want to be able to convert an incoming message to a warp message, and then I want to be able to convert a warp message to an outgoing message. So first of all, create pretty simple, and again, I would implement the from trait, but this is a type that I don't control. So the from trait for the message type, those are two foreign types, so I can't implement both of those in my completely unrelated crate here. So I'm just going to do a plain implementation of incoming message, and I'm going to create a from message. Yeah, okay. I had that backwards earlier. It's when an incoming message comes in from warp, I need to convert that to my internal incoming message type. And then when I want to send a response back out to warp, that's when I need to convert from outgoing message to warp's message. All right. So give it a result, and it's going to be an option for itself, incoming message. I'm also going to tell it that the error that could result, reason why it's a result, is because it could return a deserialization error. All right, so it's complaining because I'm not returning anything yet. We'll fix that in a moment. So let's say we want to take this message that's coming in and we're going to try to convert that to a string. So if you look here, there's a message or a method called toString, yes, that can return a string, but it can also return an error. So we're going to use an if statement that incorporates a matcher. I think there's a more idiomatic term for that, but I'm going to say, all right, let the message equal if it's okay. Oops, yeah. We're going to try calling toString on the message. And if that was successful, then that will give us this inner variable that has a borrowed string reference. And then we'll also have an else case here. And in that case, we're just going to say, never mind, return okay, none. Because in that case, that means the message wasn't a string. So clearly it's not something that we care about. Next, inside here, I'm just going to assign message to the inner value of the string. So you can see the result is that message becomes a string. Because if we went down this case, we've already returned. So it knows if we're proceeding from this point, it's going to be a reference to a string. And then I'm going to tell Serde to deserialize this from string. And actually, no, I don't want a semicolon. Adding a semicolon here means that it doesn't return anything. It would just be invoking and expecting unit to be the return. But if I take the semicolon out, the last statement in a function without a semicolon becomes the return value. So I don't have to actually say return. Do it this way. And it's unhappy, possibly because I haven't imported Serd yet, Serde. Oh no, because I'm fully qualifying it there. So then what does it not like? Oh, I know what it doesn't like. That I haven't derived anything on my incoming message type yet. So let me do just that. I'm going to derive clone. I'm going to derive debug, derive dummy from the fake library we were working with before, serialize and deserialize from Surday, EQ and partial EQ. A good set of basic things. Go ahead and import serialize and dummy. Oh, dummy's unhappy because I didn't import the trait that it uses, I think. Oh, and it might be that I don't even have the library imported yet. Yes, undeclared crate. So I need to add. That doesn't make sense though. Yeah, because fake is right there. Ah, but it's a dev dependency. And in this case, I think I need it to be a top level dependency. Yeah, in order for it to generate the dummies. Okay. So it shouldn't actually do anything if you're compiling for production. This makes it available. All right, so now it's upset. Oh, because I need the rand crate, which is probably also in the dev dependencies. Yep. Because Faker makes use of the random number generators. That makes sense. All right. So I'm not actually using the fake trait yet, but I will be. So now I've got the method that can take me from the warp message to my internal incoming message type. Now let's implement the inverse, or I guess the next step of it, going from outgoing message to the warp outgoing message type. I probably need to derive the same things for this too. Oh, and one other thing that I want to do here, Surday has a feature that allows you to kind of change how enums are serialized. So I'm going to tell it I want to serialize this with a tag called type. So the difference is if you don't do that, then it uses object keys as the type name. So there would be an object with a key called incoming message, and then a property, or no, there would be an incoming message object, and then it would have a key inside it of ping, and then just an empty value. I don't know if it's probably a null, but in any case, that would indicate that, oh, this is a ping type, but that's kind of awkward to work with, especially if you're using JavaScript on the front end or something like that. So by adding the surday tag equals type derived declaration here, I'm telling it that I would rather you keep incoming message as a single object without that kind of inner property, and use a property called type with a string of ping to indicate what type of incoming message it is. So the result after it's serialized to JSON in this case just becomes an object with a property of type that equals the string ping, which I think is actually pretty nice. That's how you would expect it to work in kind of a typical JavaScript environment. So I'm going to use that here. So I'm going to add that down here on this one as well. I'm going to tell it, oh yes, I'm going to have to add a doc string anyway. And then I always like to add the derive underneath the comment. Just going to give this one serialize, deserialize. Well, you know what? I probably will need to be able to do other things with it in testing. So I'll go ahead and give it all of the others. as well. All right. Oh, and then yes, I'm going to use the type tag still on here. All right. So next up, I'm going to this time, since outgoing message, this time I can use the from trait for message, and then take it from outgoing message to the warp message. So pass it from the handler to warp itself, which then emits it to our WebSocket client. And I'm going to say I'm using the warp message text. So reply speaking JSON. Borrow the message because that's what Surday's toString is looking for. Borrow. And then I'm just going to add an expect here. This is not sound. So anytime you're using an expect like this, know that you are introducing the possibility of a runtime error. Be aware of that. I'm just going to save time with it here now, though. I really should spell my types correctly. Oh, wow. All right. It still tells me I'm not using that fake trait. I really thought that I was using it at some point, trying to make sure that I'm not missing anything. It'll warn me. So I'll come back to that later. All right. So we've got our incoming message and outgoing message types. You can see this is a point where it would expand later on. This is where a lot of different types will grow. You might end up breaking this into multiple pieces later on, maybe organizing them around the business domains that I was talking about before. But for now, we're just going to keep it all in one file here. And then before we can implement our handler, we're going to need to find some way to manage connections. And this is something I arrived to with a lot of trial and error and testing. And it works pretty well so far. I've got integration tests written that actually deal in WebSocket events. So we'll be able to test this pretty thoroughly once I get to that point. I don't think I'll be able to finish up all this tonight, but I should be able to at least get to the handler method. So first off, let's just go ahead and create a struct. And this is going to be a new type called connections. So a new type is like a type alias that wraps a type. And in some cases, it can actually be the solution to the problem of not being able to implement a trait for a foreign trait for a foreign type. You can sometimes wrap it in a new type and implement it for that type. But the reason I didn't do that in the previous case of the MaybeUndefined is because there was a lot of built-in functionality in MaybeUndefined, built-in implementations of other traits like input object for async-graphql that I would have to reproduce. And so this more awkward way that I approached it made sense. But in this case, I'm going to use an arc, and I'm going to make it, give it a read write lock, which is a synchronization method. And inside that read write lock, I'm going to give it a hash map. And my hash map is going to map strings to the MSPC or MPSC channels library. So I'm going to give it an unbounded sender of warp messages. Surprisingly, with as many nested types as are in here, I have botched it somehow. Let's see. So we've got the opening parentheses, 1, 2, 3, 4. I need one more of those. There we go. All right, so now it wants me to start importing types. Oh, and which read write? Yeah, I didn't use the standard read write lock. I used Tokio's so that it would be compatible with the async first approach that I'm going with here. MPSC, where is that? Oh, it's in Tokio. Yeah, Tokio Sync MPSC. Um, this channel's implementation is compatible with Tokio's async model. Pull in the warp message type. Hash map just comes from standard collections. Read write locks come from standard synchronization. No, again, I always reach for the standard, but in this case, it's the Tokio version. There it is. Yes. All right. So this is my top level structure for keeping track of connections in a thread safe way. That also allows for some mutation. That's what the RW lock synchronization is doing, is allowing me to mutate that value by locking it when it needs to be written to, so that nothing else can read to it during the change or read from it. So I am going to derive default on this, which essentially is kind of similar to Go's empty feature. It allows you to create an empty instance without giving any kind of parameters. Then I'm going to implement a send, an insert, and a remove method on this. So send is going to send a message to a particular connection based on a connection ID. Insert is going to register a new connection within my hash map and return an ID for it. And remove is going to remove a connection by ID from the map. So on connections, I'm going to create my send function as an async function. And it's going to act on an instance of the connections type. And it's going to take a connection ID and a warp message from the WebSocket connection. All right, next I'm going to check to see if connection is some or none. So I'm going to say self 0. So that means I'm going inside my new type. So connections dot 0 refers to the arc there. So now I'm inside my arc, but I'm going to automatically dereference the arc. This is syntactic sugar, and get to the RW lock. And so I'm going to say read. And since this is the Tokio version of read, it is async, so I can await it with a .await. And then I can use it by calling .get. And I'll pass in this connection ID like this. Oh, helps if I don't misspell things. So you can see this is how I plan to use it. I'm going to go ahead and come back to that, though, and backtrack a little and talk about inserting and removing a connection before we actually make use of it. So this does not need to be public. I'm going to act on an instance, and this is going to be one of those unbounded sender from the channel. It's going to contain a message. And it's going to return a string, which is the connection ID that it derived for this new connection that we're saving to the map. All right, so I'm going to use a library that I really like that I clearly haven't pulled into this crate yet. So let me find the name and version number that I'm looking for. But I'm using a library called ULID, and ULID is kind of like UUIDs, but they are sortable. They're reliably sortable, which opens up a whole bunch of different use cases for seeing, was this ID generated after this other ID? You can handle eventual consistency concerns. There's all kinds of different things that you can do with that capability. And they're a little bit easier to look at than a typical UUID would be. So definitely would recommend looking into UL IDs. They're universal lexicographically sortable IDs. It's a mouthful. All right, so I think it's just doesn't want to autocomplete. All right, so let me look it up really quick. Oh, it's new. Okay. And then, so first off, if you just call new, import it first. It's got to import that. Wait, I already did import the unbounded sender, didn't I? Clearly I did not. Okay. All right, so if you just call new, then you'll get a ULID instance, but I just want to use the string from it. So I'm going to call toString. So now you can see it's turned into a string. So now I'm going to use that RW lock. I'm going to write to it. So this locks it up and says, hold up a minute. I got to make a change. Stop reading. And then I'm going to insert to the hash map based on the connection ID that we just generated. Then I'm going to give it that unbounded sender as the value in the hash map. And then return that connection ID for later use. So you can see it's the last statement in the function. It doesn't have a return keyword or a colon, so it just automatically returns the string back. So that's how you get a connection in there. And then this is us making use of the connection. Yeah, I'll go ahead and do that now. So, okay, we've got our read. So this is saying, okay, find the unbounded sender, the channel for this connection based on ID. And so here we get the unbounded sender. And then to make use of it, we're going to call connection.send message. And you can see it returns a result. So let's just go ahead and pattern match on this if statement. And let's say if there's an error, that's going to happen in the event of the connection being disconnected. So we're trying to send a message to a connection, but the connection's dead now. That's the typical case that you would see an error come in like this. Say sender is disconnected. I'll leave it at that for now. All right, and it's as simple as that. Connection.send, and we're just ignoring errors for now. Now, once you head towards production, you're going to want to make that more robust. You're going to want to handle more error cases, but that'll do for now. And then let's go ahead and implement the remove. So async. I see why in my original implementation on the other project that I'm looking at, I had this up at the top and I'm realizing, oh, that's because this is async, or I'm sorry, this is pub and the other two are private. And I like to put the pub functions up top, up front. They're the first things you see. That's your public interface. That's what people coming behind you will be using anyway. So give it to them first. All right, so this remove is also going to take the connection ID as a string reference. And once again, we are going to lock it for mutation. And since it's the Tokio RW lock, we can await that. And now we can just remove our connection ID. Boom, no more connections stored in the hash map. So here we go. This is really all we need to maintain our connections in memory. This strategy is not going to scale if you are horizontally scaling your application processes. This is only going to work on a single application process. No, I might be wrong about that. Actually, this might actually scale horizontally because the connection is maintained by the process that handled the initial request that kicked off the WebSocket connection to begin with. So how a WebSocket connection starts is with an HTTP request with an upgrade directive, and that upgrades the connection to a WebSocket inside the browser, and then that connection would be maintained by the process that handled the upgrade request. And so that ongoing process now manages its connection, and it's direct to that instance, that node of your horizontally scaled API processes. So I think this would work. The only problem would be that you can't communicate with any connections that are from another horizontally scaled instance of your API server. So if you have like a chat service or something like that, in which one user might want message another user, if you're horizontally scaling and you use this kind of strategy alone, then you won't be able to talk to all of your connections. You can only talk to the connections that are on the current node that your connection was established in. And the way around that is something like Redis, something where you can use a pub sub strategy to share those messages across all of your running instances. So I like Redis's pub sub channels for this. And that way you can maintain your connections on your separate running API processes, and then use Redis to communicate between all of them at the same time. So you can subscribe to a channel in Redis and get notified when new messages are sent to that channel across all of your horizontally scaled instances. But you don't have to worry about that now. You're still in the early stages of your project. You're running with a single node right now, so you don't care right now. That's the context that I'm looking at here. So let's go ahead and write our handler function. And I'm going to go ahead and just put it here. Actually, no, you know what? That's messy. I don't foresee this growing too much, but maybe once we do have the Redis pub sub in, it will grow. So I'm going to go ahead and add this as handler.rs. And I'm going to add this to my public mods here. Call it event handler. It's upset. Oh, because it's not events, it's handler. That's why it's upset. And then I'm also going to, no, I've already got events added to my lib. That's still complaining because handle's not there yet. Okay, I've got everything I need. All right, so build out our pub async function called handle. It's going to take the WS instance, and that comes from warp, which is the same place we'll be getting the message from. That way for now. So this is going to be, it's what we need to finish the upgrade handling. That makes sense. And then we're also going to take the context. Oh, yes. The order of parameters in this handle function depends on the warp filter. So in this case, you can see the warp path of events has and WS. That's where that WS upgrade handler comes from. Then we've got with context. That's what's passing the arc context in. And then we've also got the with auth passing the JWix. Essentially, what it boils down to is the JWT token subject here. So those three ands become arguments to the handler function. So here I have my arc with my context. And I'm not going to use the subject yet, but the subject comes from an internal library here. And I like to group external dependencies first and then internal dependencies second. All right, so the result is going to be an implementation, a dynamic implementation of the warp reply, and it's not going to return any errors for now anyway. So we've got to import this stuff, import arc, import context from my own crate, group these correctly. There we go. All right, so it's going to take those three things from the warp filter and it's going to return a warp reply. And the first thing that it needs to do, and this is all borrowed heavily from the examples in the warp repo. So definitely check out those examples, but we're going to use the onUpgrade method in that WebSocket upgrade handler instance thing. We're going to say, okay, let's assign the results of this first off as the reply. So we're going to first off say this is going to result in the reply that we're looking for. And now we're going to give it a lambda, an inline function here to actually handle things. And so I'm going to say async move. So that means this is an async lambda function, an async inline function. And move says that it's going to take ownership of the values that it captures inside the function here. So it's interacting with Rust's borrow checker to manage lifetimes correctly, essentially. So inside, let's go ahead and add a colon to that. So inside our handler, so this is the handler function that we're passing to the WS on upgrade method. And it's going to call socket.split, which gives you, oh, I probably have to import a trait, don't I? But which trait is it? It's probably something to do with the socket. Oh, I remember. This comes from the futures library. From one of these. I'm using all three of these. Okay, it's from StreamX. Stream extensions. All right, so socket split. There we go. And you can see it's returning a string, a sync, and a stream. So to make use of that, I'm going to destructure it a little bit and pull out mutable variables from both of those because I'm going to use them. All right, so I've got my writer and my reader. So now I'm going to use that, or I'm going to establish that unbounded channel that we were working with before using the MPSC library. And channels are a way of coordinating multi-threaded or async operations. Tokio MPSC. So we've got, we've got the sender and receiver. All right. So then next I'm going to create a mutable unbounded receiver string or stream. Oh, whoops, not the receiver itself, but the stream. Pass it that RX. right, so where's that coming from? That might be a library that I'm not importing yet. It may well be a library that I haven't added to the crate yet, which I think that's probably true. That's what it's supposed to be, but yeah, let me go find the cargo name for that. Okay, found it. Add it down here. Okay, so then that should pop together. Yep, looking good there. All right, I'm getting back to my handler now. All right, so next I'm going to use Tokio to spawn a background task on the event loop. Again, I'm using async move here. Using a colon because this is going to return unit, which means it doesn't directly return anything. It acts up via side effect. I'm going to use the while let syntax to create a while loop while pattern matching on the receiver. So when the receiver receives a message, so calling .next on the receiver, and since this is the Tokio version, I can call .await to await it. And then I'm going to use that writer to send message. And do some error handling. Error print line. So this is going to happen if WebSocket has trouble sending. And let's go ahead and await that at the end. All right, so that's our task that we're spawning. But now we need to go ahead and add our connection to the hash map that we created in our connections type. So I'm going to use context, which I think I'll have to add the connections to. I don't think it's there yet. But once it's there, then I'll insert this new connection and the connection ID will be what it returns. But yes, connections is not there yet. So I need to add that to my application context. And to do that, I'm going to go into lib here and add it to this routine here that kind of constructs my dependency injection here. So we saw before I had just created the easy default deriver on this. So that means I don't actually have to have any parameters or anything. I can just create a default instance explicitly like that. I got to import it. Yep, I knew it was going to throw it up there, but I want it down here in my internal group of imports. And then I also need to spell things correctly. That's quite important. All right, so I've got my connections here. I need to also add them to the type. So this is my context type. I'm going to have to give it a doc string. All right, so I've got the connections there. Now I need to pass it in down here. So you can see it's highlighting self as not having all the fields now since I added that. Oh, and it's plural. There we go. And that should be it. Now we've got it in the context so we can make use of it here. So this should now be connections, insert. Oh, insert doesn't return anything. Did I? No, it does. Insert. Oh, it's saying it's private. Okay. I need to make it public. And the reason I had it private before was because in my other project, the handler was in this same module. But in this case, it's not. There we go. Now connection ID comes out as string like I was expecting. So now I can take that connection ID. Got to get back to where I was at in the other project really quick. Oh, yes, I need to do the read now. So I need to take that WS and WS read, the reader, and then wait for the next result there. Again, with a while let. There we go. So you can see this is going to be a result with a WebSocket message or an error. So inside here, we need to handle that result. And if it was okay, if it actually has a message inside, just return the message or assign the message to this variable. Otherwise, if it's an error, let's report it for now in the console. So this is what would show up in your running container logs or your Lambda function logs or something like that. I wouldn't recommend running a WebSocket server in Lambda right now, though. There's definitely some complexities there, especially if you're going through API Gateway or something like that. Configuring WebSockets can be challenging. I would definitely recommend something like Kubernetes or ECS or something along those lines. I'm going to give it a little bit of information here using the string formatting that Rust provides. So I'm going to pass it the connection ID and the error in the event something goes wrong. So that way I've got at least something to help me debug. And go ahead and break that loop. All right, so at this point we should have, yes, message is a message now. So we've gotten past that hurdle. Now let's go ahead and convert that to the incoming message type that we created just a bit ago. So that is going to return. Oh, well, let me finish what I was doing here. Yeah, it returns a result. Okay, so let's see why this is upset. We have message. Oh, I'm not importing that. That's why. When I don't have a return value yet, it always makes it a little bit harder. In fact, I'm going to just do. Oh, no, I can't because I don't have a reply to return. So, yeah, I just have to deal with the ugly highlighting here for now. All right, so we've read the message. We have taken the message out of its wrapper. Now we're converting it to an incoming message, which is our internal type. So now we're looking to see, okay, did it actually get converted to a message. This is that string check that we were looking at. If it was a string, then yes. Otherwise, if it's not text-based, we'll skip it. But for this, we're going to use this route message method that we haven't created yet. This is something that will exist later, but it's a placeholder for now. Oops. So route the message if there was a message. If there was no message because it wasn't text-based, then just pass, skip it. And then if it was an error, let's be noisy about it. But in a production project, you're going to want more robust error handling here, most likely speaking to an error reporting service. And then more debugging information in that error. I always like to leave myself clues. All right, so this should handle the cases of receiving and sending a message. Let's see. Yeah, let's go ahead and print a little message at the bottom here. This is going to be when the connection is done, when these readers have finished reading and signaled that they have reached the end of their channel lifetime. We know that the user is disconnected, so indicate that. This connection ID is no longer active, so goodbye. And finally, we can now remove that connection from our connections map and then get rid of, oh, I could have come down here. I could have just returned OK reply all along. Yep, that was my own failing there. All right, so the red highlight is gone finally. You know what? Remove needs to be public too. So yeah, since I moved the handler out to its own module, all three of these need to be public, and that's okay. So now all we've got is our placeholder, our route message that needs to be implemented. That's going to go in the router.rs. But I think I've just about come to the end of today's stream. I'll tackle the route message in another session. But you can see where this is going. Essentially, there's the router, the outer router. This is the HTTP router that handles the upgrade messages. So that's where connections go. They're handled and upgraded, stored in our RW lock synchronized ARC. And then the handler is called to handle that upgrade, add the connection to the map, and then handle events when we want to send or receive a message. And when a message is received, it calls this route message method to decide what to do with it. All right. Yep, I think that's enough for today. I'm going to wrap it up, but thank you so much for hanging out with me. I hope this has been really helpful in kind of looking at a traditional HTTP server speaking GraphQL in Rust. I think Rust is a fantastic language. I've been a type system nerd for most of my career and love working with languages like Haskell and OCaml and things like that. I was a big fan of PureScript in the JavaScript world, and also Rescript, which is derived from OCaml with a bunch of tooling around it. So this Rust kind of caught me off guard at first. I didn't take it seriously because it didn't approach the problems the same way as other languages like Haskell I've worked with do. But I've come to really love the way that it approaches it, especially with the borrow checking, the ownership and lifetime tracking that kind of solves the same problems in a completely different way with a totally new approach. So I would definitely recommend checking Rust out. I've definitely really enjoyed getting to know it better and learning how to navigate some of its complexity, because it is complexity. There is a lot there, but once you learn it, it helps you forever. And I found that it helps me code in other languages. Like my day project right now is a Go project, and I've been using Golang, I think, in a safer way, in a more tight and strict way, because of the strategies that I've been learning with Rust. And likewise with things like TypeScript. I haven't touched a TypeScript project in a while, almost a year now. But when I was learning Rust back then, it was helping me write better TypeScript as well, because thinking of memory allocation, thinking of ownership and lifetimes, is something that is abstracted away for you in those environments. But it's no less important. It's just you won't always know what to expect when things go wrong if you're not thinking about ownership and lifetimes. And similarly in Golang, Go's garbage collection is kind of similar to TypeScript's in some ways. And you can run into the same kind of issues if you're not thinking about shared ownership and lifetimes. So anyway, thanks again for hanging out with me. I will be streaming a Rust review on Monday, where Alex Kaliris and I will go over some of the latest articles to come out of the Rust community over the last couple of weeks. And I may do more spontaneous live streams where I continue to work through the router, the WebSocket router this time, and make it a little further there. And then I'm also going to do some streaming around some of the Go work that I've done. I've got an event sourcing CQRS library that uses DynamoDB as an event log store that I'm planning on open sourcing soon. So I will cover that as well. Thanks again, and hope you have a great night.